So when I'm doing these, in fact, this is the one I did last hour. Cotangent theta is equal to I'm going to do a lot of drawing today, so that might be helpful to have the visual so you can connect it. So cotangent theta is equal to 8.31. One of the things you'll notice is your calculator does not have a cotangent button. And because it doesn't have a cotangent button, it really doesn't have an inverse cotangent button. There is a way to do it, but it's pretty complicated. So I'm not going to teach you the route of how you actually can do inverse cotangent because I think it's completely useless because I usually screw it up. And if I usually screw it up, the risk of you guys screwing up is going to be exponentially higher. So let's don't even go that route. We're just going to make this a lot simpler. What button do you have on your calculator? You do have a tangent button. So we're going to change cotangent into tangent. How do I change it into tangent? What happened? What actually happened to change cotangent into tangent? You did the reciprocal. So if I do the reciprocal of that side, I got to do the reciprocal of the. So it's going to be 1 over 8.31, whatever that is, and I really don't care what it is. We're going to let the calculator do the work anyways. Now, the reason we're not doing sine and cosine here, and cosine and sine here, is we're not using the unit circle. See, if we were using the unit circle, I think about it as cosine over sine, and just use my, because I know all the cosine and sine values for common angles, but I don't know what 1 divided by 8.31 is, and neither do you. Okay? So what I'm going to do here is I'm going to let the calculator do the work for me. Now, let's review some things. We want to know where this is positive. So let's first of all talk about that. Where is tangent positive? Quadrant 1 and in quadrant what? 3, which I think is interesting. We'll talk about that more today. Let's review for a minute what your calculator actually tells you when you're using the inverse trig function. For example, if I'm doing inverse cosine or inverse sine, let's review real quick. What's the domain for inverse sine? You have to have these memorized or you're doomed on tomorrow's quiz. Negative 1 to 1. People are like, you're not going to be here tomorrow. It's not fair. You know what? I was going to do an unannounced quiz. So I think I'm nice just saying there isn't even going to be a quiz. Okay? I'm reviewing right now. So that's why I'm doing this, because I'm not going to be here tomorrow. All right, domain negative 1 to 1. What is the range? This is humongo, okay? This right here, if you don't get this part, you're going to have a hard time getting these problems right. Because the range tells you where your answer's at. I know that when I get answers on the calculator, they're always going to be between negative pi over 2 and pi over 2. Which can be a problem, especially when it's in that fourth quadrant and negative. Because if you give me that answer, you're going to get the problem wrong. You're going to have to find the answer between 0 to 2 pi, and we need to know how to do that. So that's what we want to go through today. So there's inverse sine. What about inverse cosine? What's the domain? Negative 1 to 1. Good. What's the range?
0 to pi.
0 to pi. That's interesting. Okay. Inverse tangent. What do we got? That domain, I love that because you don't have to worry about here. You have to worry on inverse sine and cosine. You have to remember there's possibly there's going to be problems where it could be no solution, right? So if we get problems where it's no solution, we have to remember, oh, how does that happen? Well, when you take the inverse sine or inverse cosine of something bigger than 1 or smaller than negative 1. This one's okay though. Domain's all real number. It won't matter there. I can take the inverse tangent of anything. The range though is important because that's what the calculator's going to spit out, which is about what we're about to talk about here. Negative pi over 2 to pi over 2. Why do I not include the negative pi over 2 to pi over 2? Why will the calculator not kick these answers out? Because there's asymptotes there. It won't give you something that's undefined. All right? So when I look at this, I'm looking for it's positive, which is kind of nice this time because that means it's going to be between the 0 to pi over 2, which actually is something I want because I want the answers between 0 to 2 pi. So that's actually a good thing. So hit second tangent now of 1 divided by 8.31. Don't worry about the 1 divided by 8.31. Nobody cares about the 1 divided by 8.31 because the calculator's going to do it. What do you get?
0.12.
By the way, before I write that down, let me tell you, you really should get in the habit of writing down what you actually did on your calculator. Because if you knew what to do on the AP exam, if you knew to use the inverse tangent of 1 divided by 8.31, that's the exact value. And let's say you accidentally screw up the decimal because you accidentally hit the button wrong, they will actually still give you credit if you have that written down.
Partial credit?
No, they'll give you full.
Oh.
And if you fail to write that exact value down, but accidentally just hit the button, you accidentally hit the plus sign, and you didn't notice, you hit the inverse or the inverse sine button or inverse cosine button instead, and you accidentally hit the wrong button and you did it wrong, and you get the wrong answer, you're going to lose the whole point then. Versus getting the whole point if you wrote down the exact value. Now, a lot of times on these calculator parts, they want you to round it, and they always have you round to 3 decimal places on the AP exam, but the direction said round to the nearest hundredth, which means how many decimals? 2 decimals. So what did you get? 0. I think you said 0.12. Now, I like this. Okay? I really like this. I think this is good to explain here. And I love drawing pictures because I think you have a mental model that you can look at and say, okay, that makes sense to me why that works. 0.12, I don't think a lot of you understand how big that angle is. What? How big is 0.12? Is it big? It's very small. If you don't trust me, everybody take 0.12. You got it on your calculator. Hit. How do you change that to degrees? Because you guys know degrees. Times 180 divided by pi. Times it by 180 and divided by pi, and we'll see how small it is. It's approximately 6 degrees. I mean, it's a really small angle. This is not very big at all. 0.12, that's probably bigger than it should be. This right here, 6 degrees is all it is. So this 0.12 radians, not very big. And we know it goes from 0, this is 1.57, this is 3.14, this is 4.71. Do you have to have those memorized?
Yes.
Yes, you do. Unless you, well, you do have to, I guess you don't have to have them memorized because if you got the calculator, you could, if you forget that pi over 2 is 1.57, since it's on the calculator part, you could go pi divided by 2 and get the 1.57. So I guess you don't have to have it memorized. But it's kind of handy to have it memorized. Because then you look at this and say, okay, 0.12, that's between 0 and 1.57. That's which answer? Quadrant 1. But your calculator doesn't give you quadrant 2. So you have to know how to take what you got. And sometimes what you got is not even the answer you're looking for. So sometimes you have to get the reference angle off of it and then use it. This one, this is an answer, but it's also a what? It's also the reference angle. So now I got to take 0.12, come over here to quadrant where? 3, which notice that's a straight line that's really important today. That's 0.12, so how am I going to get quadrant 3? I'm up to take 3.14 and add the 0.12 to it to get the whole angle. So you just take the 0.12, okay, 0.12, and add pi to it. So what do you get for the final answer? 3.26 or 3.25, something like that. Does that help? Okay, let's keep going. Keep going through some of these. We'll go to another. We'll just keep going 4 by 4, okay? Next 4, are there any questions on this 4? Does anybody want Lake's Cafe?
No.
Has anybody ever had a 4-boy at Lake's Cafe? No, craving a cheeseburger. Oh, wait, there's chicken nuggets. We can't do that. All right, no questions on these 4? Can I move on? What about these? Interesting enough, you didn't even need your calculator for 13, 15, or 16. Did you know that? It said in the directions to round to the nearest hundredth, but you actually could have done 13, 15, and 16 without a calculator. You want me to demonstrate? Okay, Joe looks intrigued. All right, first of all, let me deal with 13. Everybody looks at 13 and they're just all like, oh, you know, it looks like some kind of quadratic formula spastic thing going on. How can you just get rid of the fraction so you don't have to deal with it? Multiply both sides of the equation by 3 and let's just get rid of the fraction. It's not that big of a deal. If I multiply everything by 3 in this equation, when I multiply the other side by 3, what are you going to get? Negative 9 plus 3 tangent theta. Billy, what color is the pen?
Black.
Are you sure?
Yeah.
Are you sure the color of the pen is black? What color is that?
Oh, I'm saying meant that.
That's the color of the pen.
Oh, that's green.
You sure it's green? Because we had a whole discussion yesterday, a philosophy discussion on is really the same, what you think is green, what I think is green. Maybe my green is red. How do we
Still
know?
green, though.
Never gonna know. This is blue, but my blue might be your red. Think about that for a while. I love it. All right, 3 tangent. All right, what happens here on the other side? The 3 just cancels. So you got -9 minus root 3. What happens to the -9s? You can drop those babies off. All right, 3 tangent theta is equal to negative root 3. What do you do now? Divide by 3. Ooh, look at this problem. I don't need a calculator for this one because I know where tangent is equal to negative root 3 over 3. I can change tangent to sine over cosine and think about that and say, okay, quadrant where tangent is negative, where's tangent negative? Quadrant 2 and quadrant what? 4. Then I can say, okay, to get root 3 over 3, I need the root 3 over 2 to be on bottom, the 1/2 to be on top, the 2's would cancel. Would that give me root 3 over 3? Yeah? And then what reference angle is sine 1/2 and cosine root 3 over 2? Pi over 6. So I can say, all right, quadrant 2, pi over 6, that would be 5 pi over 6. Just watch. And then quadrant 4, pi over 6, that'd be 11 pi over 6. Take your calculator out right now and type in 5 pi over 6.
So we do need a calculator.
Just to prove that we did it right. We do not need a calculator to do this problem. What is 5 pi over 6?
2.62.
Ah. What is 11 pi over 6? Yes. Okay.
Wow.
All right. All right. So this one you can do without a calculator. And if you gave me these answers, I would be okay with that, even if the direction said rounds in the nearest under. I'm actually more okay with the exact value than I am the decimal answer. The decimal answer, you had to do what? You had to round it. It's not exact. I'm much more happy with 5 pi over 6 than I am 11 pi over 6. Now, if the direction says do something, you need to do it. Okay? So don't give me, I'm not trying to get you to rebel, okay? Don't rebel against the system. All right? This ain't rage against the machine. All right? Okay, it's an 80s thing, but there is a band called Rage Against the Machine too, and I thought you would get it, but never mind. All right, 15 and 16. Do you need to see those? Now, you certainly can do them with a calculator. I think it makes more sense for us to look at number 14. Can we look at 14?
Yeah.
All right. So, can you help me a little bit? What's the first step? We always remember. Don't forget that, regardless of how complicated this gets, and it's going to get complicated. Okay, Monday and Tuesday is going to be the end of the road for trig equation. It's going to get really jacked up, and then Wednesday you're going to take the common graph and solving trig equations test. All right. And when it gets really, really hard, always go back to this. Solving equation is still the same thing you did in 9th grade. You're just trying to get a variable by itself. You're just trying to isolate the variable. And one of the things you have to realize when you're solving a trig equation, the way to do that is to get the trig expression isolated first so that I can use inverse trig so that I can get that variable by itself. So when you look at number 14, I don't care what kind of fluff is on it. And there's going to be some fluff on it. Get rid of the fluff, get it down to a trig ratio so that you can use an inverse trig ratio to get it down to theta. Okay, so what's the fluff here? Get rid of the 1/2. How do we get rid of the 1/2? All right, multiply that by 2 because I don't do math. What is it?
Negative.
Negative 0.43. All right, is equal to cosine theta. You good with that? Now I'm trying to, did you have a question real quick?
I have to go to the office quick because my therapist is here
Okay.
for my shoulder.
All right, so that's negative. Go ahead. Is it now?
Yeah, I'll be back.
Better be. Okay, that's negative, so what quadrant are we in? Quadrant 2 and quadrant 3. Okay, you good with that? Now, let's do the inverse cosine. So theta is going to be equal to inverse cosine. This one you have to have a calculator for. There's no way you're doing this without a calculator. All right, do that for me. I don't do math. 2 point, are you sure? Yeah, I agree. 2.02. Now, that's one of the answers. This is where it gets interesting, I think. So what you've done, and I think visual helps people, so let me be visual, okay? Here's 1.57, here's 3.14, here's 4.71, I don't think I need this one over here, but there's 0 if you want to know in 6.28. 2.02, is that one of the answers I was looking for? Yeah, that's the quadrant 2 answer. So I can go over here and say, okay, sweet, I got the 2.02. Anybody go to Hunger Games last night at midnight?
It's tonight.
Is it tonight? I'm so there.
It's at permit like 8. Like it's not at midnight.
Oh, it's at 8?
It's like 6 or 8.
That's not. I'd like to be at
It's
midnight.
at 8.
2.02, are you good with that? But how do I get the other answer? You got to find the reference angle. You've got to figure out what this guy is right here. So how do you figure out what that guy is? You take that the whole guy, 3.14, and you subtract this guy, and you get that guy. Do you know which that guy we're talking about? All right, yeah, that guy. All right, you take pi, the whole angle, the whole thing, all the way to this axis, and then you subtract off the 2.02, and you'll be left with this. It's just angle addition postulate from geometry. All right, so what do you end up getting there? 1.12. Now, is that what I need? Here's the thing. Some of you are going to put 1.12 as the other answer tomorrow. It's not. What do you do with the 1.12? You come down here and you say, I need to take 1.12, and now I need to do what? Add it to pi. So you take 1.12 plus pi, and that'll give you the 4.27, the other answer that you're looking for. Does that help? Is the road been lit up? Okay. All right. Now it's the yellow brick road. Not that Billy would know. All right, 17 through 20. Any questions on 17 through 20? I think most of you, just a lot of fluff here. Like, it's not magical to, oh, I gotta add the 2 over and I gotta divide by 3. Just fluff.
So for 17, you change it to tangent?
I would. No. On calculator one, I would. Non-calculator one, I'm going to change it to sine and cosine. Because unit circle is easy to think about in terms of sine and cosine. So I'm going to get 1 is equal to cotangent theta. So I'm saying tangent I don't think is going to help me, but changing it into cosine over sine helps me. But then I'm thinking about, okay, how can I get it to equal 1? Well, where are cosine and sine the same? Pi over 4s. And then you're saying where it's positive, quadrant 1, quadrant 3 with pi over 4s. Okay? Number 19, get rid of the fluff first. Okay, I'd multiply everything by what? Should get rid of the fractions. 4. So you have 16 plus root 2 is equal to 16 minus cosecant theta. So I went ahead and just cleared the fractions because they're annoying. It's like so of 2's. Okay? What happens to 16? Cancel. That's really nice. So then you get root 2 is equal to negative cosecant theta. Then you flip both sides, so you get root 2 over 2 is equal to negative sine theta. And then you don't want the negative, so you move the negative to the other side. So now you're looking where sine is negative root 2 over 2, which is 5 pi over 4. Okay? Helpful? Okay? All right, I really need to get to the next stuff, so we got to hurry up a little bit here. 21 through 24. A lot of kind of same stuff. If you need me to do another one, that's fine, but I did 21. Let's skip that section. You can watch the video. 25 through 28. These are just getting into more fluffy problems, okay? And what I mean by that, there's just more algebra. I literally had somebody miss number 25 last hour, not because they didn't know what they're doing, just they made an algebra mistake, okay? What I mean by that, you just got to decide how you want to move things. I'd probably move the negative 2 sine theta to this side, and I'd probably move the negative 4 to this side. Do you have to show any of that work? Please don't, okay? So then you're going to get sine theta is equal to negative 1, and you're like, oh, that's simple now. I know where sine is equal to negative 1, 3 pi over 2. Okay? You don't have to show a lot of work. In fact, we want you to show less work when it comes to algebra, but just be careful. How can you guarantee usually that your algebra correct? Show work. How can you guarantee that you're going to make a Carousel? Show less work. And I'm asking you to show less work. So I'm asking you.
To make careless errors.
No, I'm not asking you to make Carousel, but I am putting you in a position where you probably could make more Carousel. So you just got to be careful when you're doing the work in your head. Okay? Be very careful when you're doing the work in there. Why am I asking you to do less work?
Save time.
Save time. But as we save time, the risk for errors, careless errors, goes up. So we got to be careful. There's a trade-off a little bit, but the trade-off, I think, for the long run, as your algebra gets better, I think the trade-off's worth it. All right, 27 through 30. Let me talk about 29 through 32 and tell you why you can just add a plus pi in. Does it matter which one I do? Do you have a preference? Cotangent, you want tangent, which one do you want? 29, fine. All right, so tangent, I'm going to think of this as sine over cosine is equal to negative root 3, because since I'm doing unit circles, since I'm not actually using the calculator, I'm not going to, if I was using the calculator, I wouldn't even think about it as sine is cosine, I'd just use my inverse tangent button. My calculator's going to do all that work. I'm looking for its negative. What quadrants is that in? Huh? 2 and 4. Now, let me show you something here, because it says find all solutions. All solutions, find all of them. Okay? Now let me show you why they only showed you one. Because how many answers did I say is there between one rotation? There's 2. Tangent only has. Tangent, you only need to do 1. Because tangent doesn't take one full rotation to start repeating. How many rotations does it take for tangent and cotangent to repeat? Remember when we were doing graphs? What did we say the period was? Fundamental period was for tangent and cotangent. It was pi. So it only takes half as much to repeat. So when I look at this, so first of all, let's just figure this out and I'll show you what I mean. So I need a root 3. Well, there's only 6 possible answers you got. 1, negative 1, 0, root 3 over 2, 1 half, and root 2 over 2. You know you're not going to use 0, 1, and negative 1. You know you're not going to use root 2 over 2. So now you're down to 1 half and root 3 over 2. So which one's got to go where? Well, if I put the root 3 over 2 on top and the 1 half on bottom, is that going to give me the root 3?
Yeah.
Yeah, because then the 2's will cancel. What reference angle will that happen at? Well, what reference angle is sine root 3 over 2 and cosine 1 half? Pi over 3. So this is what we've got here. Now, let me show you why I only showed you 1. I want to explain something here because it's going to come up again today. You only ever have to, when you're looking at this visually, you only got to give 1. And to give all the solutions, they put a plus pi k. But I was telling you yesterday when we do all solutions, you put a plus 2 pi k. Well, you could do that. You could find both and put plus 2 pi k. But let me show you how ridiculous it actually is. So when I go to find these solutions, 2 and 4, what do you notice? Well, in quadrant 2, you got this one right here, which is the 2 pi over 3. Does everybody agree with that? So when you list that solution, you're like, okay, 2 pi over 3 is one of them. I like that. Plus 2 pi k. That'll give me all the angles coterminal with 2 pi over 3. Agreed? But then you go over here and you go to quadrant 4, and you get this one, which is what? I'm going to really light something up here. 4 pi over 3. And you're like, okay, I want to give all solutions, general solutions. All solutions means list them all. So now you go 4 pi over 3 plus 2 pi k. Huh? Yeah, 5 pi over 3. What are y'all smoking? All right, 5 pi over 3. 5 pi over 3. And you're looking at this, you're like, sweet, I got all the solutions. I went 2 pi over 3 plus 2 pi k, 5 pi over 3 plus 2 pi k. But this is really redundant, or really unnecessary, because I could catch them all. Because if you realize that it only takes half the amount of time for tangent and cotangent to repeat to get the coterminal angles there, you can actually catch them every other one by just using plus pi k. Because this forms what? What do you form here?
Straight line.
And the reason that works is because tangent and cotangent, their unit circle values are symmetric about the origin. And you get this straight line going on. And how far is it from here to here on a straight line? Pi, 180, right? And so you get this going, you got, oh, I can add pi and I get there, I can add pi and I get there, I can add another pi and I get there, and add another pi and I get there, add another pi and I get there. You know, now I got a radar. Okay? Boop. No? And so, what?
So then pretty soon you have a nice looking pumpkin.
Oh, pumpkin, yeah. I was thinking radar, like, you know, the little radars that got the ships on them. Boop.
Oh, the season's true too.
All right. I like radars. Boop. All right, so anyway, so we got this radar going on, but every pi radians, so what you can do, instead of, I would have no problem you listing it this way, but they always take the path of least resistance. In other words, they always take the simplest form. This is more, I mean, is this more complicated? Yeah, because you're doing two equations to describe all the solutions. They've got one equation to describe all the solutions. Now here's the dealio. You just got to pick one of the solutions. They picked the 5 pi over 3. Could you have picked the 2 pi over 3? Yeah, you could have picked the 2 pi over 3. And all you realize is instead of, whenever you're dealing with, listen, whenever you're dealing with tangent, cotangent, to get all the solutions, you just need to find one of them and add pi k. You don't need to find both and add plus 2 pi k. The reason you have to do it for sine and cosine, watch this. Sine, one of the answers is here, one of the answers is here. Is that in a straight line? No, then you have to add plus 2 pi k to get to that one. Then you have to add plus 2 pi k to get to that one. There you have to have 2. For tangent, cotangent, you only got to have 1. You could just pick one. They picked the 5 pi over 3. We could have picked the 2 pi over 3 and just add pi k. Butter. Okay?
You gotta show us that video.
Any questions? That was good explanation.
Yeah, so your recordings.
Yeah.
Don't you need them, right?
No, it's okay. It'll just be a little bit silent. They'll have to listen on one. Okay? Any questions? All right, good. You guys are good. You guys rock. All right, the rest of this, I think, is just more stuff. And yes, Billy, to answer your question, yes, when it's sine and cosine and secant and cosecant, you're going to have 2 equations to do it. You can't avoid the 2 equations with sine, cosine, secant, cosecant. You're going to have to find both answers and then tack on the plus 2 pi k to get all the solutions. Okay, check those real quick. Let me just scroll down and get the rest of this done, and then I want to get you started on some practice you're going to do tonight, which might be extra credit for the quiz tomorrow. I don't have any review tonight. I mean, I can give you some if you want. Do you want review? Or just want to work on your
Like an optional.
And public
I can put an
speaking,
optional
make it
review up there.
That'd be great.
Because I redid it on the test.
I'll put an optional review with an answer key out.
So is tonight's homework not the same as this?
No.
Homework?
Be extra credit possibly for the quiz. It's solving equations still. We got to keep going. But I'm not going to put it on the quiz tomorrow. All right, there's the last ones. Check them real quick. Again, same stuff. All righty, go to Moodle and get your calculator out. When it's all solutions, you got to remember to put plus 2 pi k. All right, this is legit. Can I erase this? Can I move on? Okay, so the next one, trig equations with algebra. We're going to be working on this the rest of the try. It's got like 12 pages in it, 16 pages. It's another textbook I got that, or a workbook that I had on trig equations by some lady, I don't know. I just use it, it's good. Now, they have notes, since it comes from a textbook, I have notes on the first couple pages. And then we get to the problems that we're going to look at today, and I want you to have your calculator out. So have your calculator ready. All right, so graphically solving equations. Now, they've got some notes, and they kind of show you how to do this. I'm going to show you the algebra way. I'm going to give you a mental picture with the why it works. So let's take a look at this first one. We're only going to get through this first one, and you're going to try these problems tonight, 1 through 8, and we'll go over them on Monday. So that'll be the only thing you got to have done for Monday. You don't have to do it tonight, but there might be an extra credit question on the quiz tomorrow, so if you want to know, give it a try. All right, so here we go. Number 1, sine 3x equals 3 half, root 3 over 2. Here's where it gets really interesting. And the directions here talk about, it says in the directions, it says find the, come on. It says find the general solutions. Anytime they say general solutions, they're really meaning all solutions. Find all the solutions. Find general solutions. They're not wanting you to be real specific. They're not saying specifically between 0 to 2 pi. They're just saying just give us all of them. So now we know there's an infinite number of possibilities. Now, what you need to understand is what happens when you start tinkering around with the trig identity really, really changes things. I'm not talking about fluff on the outside. I'm talking about within the trig ratio. Like number 2, you see the trig ratio squared. That has its whole set. That has its own set of problems. The ones that I really want you to pay attention to are not necessarily squared ones, because I can tell you how to do square ones in about 2 seconds. You ready? take square root of both sides and remember the plus or minus. Which means if there's a plus or minus, how many solutions are there now? Not 2, but 4. Because now you're not just looking for where it's positive, which is in how many quadrants? 2. You're also looking for where it's negative, which is another 2 quadrants. So now there's 4 answers you have to deal with. And then if they want all solutions, that means you got to go get all 4 answers, and they give me plus 2 pi k on all 4 answers.
So if it was cubed, would it be 12 answers?
No, because there's still only a plus or minus. And cubes don't even have a plus or minus.
5 to the 4th then.
Still only plus or minus, so you still just got 4. Now, we can't get 12 answers, and I'm going to show you how we can get 12. We get 12 answers and more than 4 answers and 6 answers and 8 answers. This next one, this one has 6 answers. That one has 4, that one has 4, that one has 8. If you're doing one rotation. So how are we going to get those answers? Well, I'm going to show you. So what you're going to do here is understand that when you start manipulating, specifically when you start changing the period for a trigonometric function, you drastically change. You affect how many solutions there are. You are going to affect the number of solutions that are out there. Okay? And that's what we've got to go after. Okay? So let's take a look at sine 3x is equal to root 3 over 2. And the best way to explain this is always start with a graph. I want you to think about this. And you don't have to write this. You can if you want. It definitely helps. I want you to think about one rotation, which would be from 0 to what? 0 to 2 pi. But if I'm going to think about sine 3x over one rotation, you need to understand sine 3x has a period change. What is the period for sine 3x? 2 pi over 3. So you need to, first of all, deal with the 2 pi over 3 period. So if I'm going to graph this, I'm just going to do this because I think you'll see why there's 6 answers here as soon as I graph this. 2 pi over 3, what's half of 2 pi over 3? Pi over 3, what's half of that? Pi over 6s. And then that would be what? Pi over 2. And then if you graph this, sine starts where? Middle. So you go top, middle, bottom, middle, and you get this. But I still want to know all the solutions in one rotation on the unit circle. Have I went one rotation on the unit circle? No, I need to go all the way up to what if I'm going to do one rotation on the unit circle? I got to go all the way up to 2 pi. So I've got to count this out all the way up to 2 pi. And watch, you will notice what happens here. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, what's the next one? 5, what's the next one? 6, which is pi, what's the next one? 7, what's the next one? 8, which is 4 pi over 3, what's the next one? 9, which is 3 pi over 2. 10, 5 pi over 3. 11. And then we're out here to 2 pi. You with me? All right, let's keep plotting. So it was at middle where I left off, right? So we're going to go back where now? Top, middle, bottom, middle. How many periods have you completed now? 2. Top, middle, bottom, middle. How many periods have you completed now? 3. When we were changing the period, I didn't tell you this because I wanted to wait until we got to equations, but this number here is huge because not only does it change the period, but it changes the number of times you'll complete that cycle within the fundamental period of sine. The fundamental period of sine was 2 pi. We know that it takes one complete rotation on the unit circle to hit all the values for sine. But when you change the period, now what you've really done, yes, the period changed to 2 pi over 3, but what you just said is now we're going to complete 3 cycles in 2 pi radians. If you change that to 4, how many cycles are you completing in 2 pi radians? How many times are you going to complete the period before you get to 2 pi? 4 times. How many times are you going to complete the period before you get to 2 pi? 2 times. How many times are you going to complete the period before you get to 2 pi? 3 times. Now here's why you increase the number of solutions. Because you're still going to look for all the solutions in one rotation and then give all the solutions for every rotation. So you start with, remember, we always go find all the solutions within one rotation on the unit circle, and then you can list all of them. Does that make sense? Okay? It's no different than what we were doing. So here's why. Look at it. If I'm trying to figure out when sine 3x is equal to root 3 over 2, somebody tell me with the calculator, where's sine? And we're going to go ahead and do this with the calculator next because this is the new thing I want to teach you. Root 3 over 2. What is root 3 over 2 as a decimal? What is root 3 over 2? I don't even get that. What is that? can do that now, like it'd be helpful.
0.86.
0.86, just make sure everybody can get 0.86, okay? That means 0.86, ready? Is right here. Do you see it? How many times does sine 3x equal 0.86 from 0 to 2 pi? 1, 2, 3, 4, 5, 6. So how many solutions are there? There's 6 answers between 0 to 2 pi. 6. Now, here's the awesome part about this. I'm going to show you how to use the calculator, how you can get these 6, okay? So, just a second, I'll show you how to do that. There's 2 ways you can do these problems. The all solution way is simple. The all solution way is awesome because you don't have to do a lot of work for the all solutions. But as soon as I change this from a problem of finding all the solutions to finding the specific number of solutions from 0 to 2 pi, then you got to go track down all 6. It gets to be a real pain as soon as I say from 0 to 2 pi. Because now you're going to specifically have to go over how many ever there are. So like for this one, you're going to have to go over 8. You're going to have to look for 8 answers from 0 to 2 pi. This one you're going to have to look for 6 answers. This one you're going to have to look for 4 answers. This one you're also going to have to look for 4 because you're going to take square to both sides and there's going to be a plus or minus. And that one's going to be easy. You can do that one with that one. Alright? Now let me show you your calculator. Get your calculator out. And I don't know if you've ever been taught this, but I'm going to show you something so awesome that you actually use a lot on the AP exam. How you can solve an equation with the calculator. You've never been taught. Did you know your calculator solves an equation? Alright, here's all you do to solve an equation on a calculator. You go to y equals. Ready? It's really cool. And it's a lot simpler than you think. You go, first of all, whenever you have an equation, you always put the left, it doesn't matter, the left or right. You put one of the sides of the equation into y1, so I'll do the left side. I always put the left side into y1. And then I put the right side of the equation into y2. This is good stuff. You'll use this. In fact, this just made your world a lot better down the road. Some of you won't realize it for another couple weeks, but then in another couple weeks, you're going to be like using this all the time. Okay? So, anytime you want to solve an equation on your calculator, all you got to do is put both sides of the equation in y1 and y2. Left side in y1, right side in y2. It can be the other way if you want it to. It doesn't matter. Now, we're actually going to figure out what have I got here. Notice I replaced it y1 equals y2. What do you think we're going to do when we graph this? We're going to look to see where these two things are equal, which is simply looking at where they what? Intersect. Now, we got to set up our window. So ready? I want to just do from 0 to 2 pi today. So we're going to go to window. Everybody go to window, W-I-N-D-O-W. And since I just want to see from 0 to 2 pi, let's set up our window from 0 to 2 pi. So what would the x-min be? 0. What would the x-max be? So you're going to actually have to type 2 pi. Which after you hit enter is going to give you 6.28. X scale. Since we already divided it up, let's divide it the same way we have it up here. So let's go ahead and put it in pi over 6s. You probably wouldn't have known that. You would have just had to pick something. But since we already graphed it by hand. Now, y min and y max, I'm going to give you a hint here. Since the amplitude is only 1, everybody see the amplitude's 1 all the time? You don't need to see that far above it, and you don't need to see that far below it. So I always just say go 1 above, 1 below. So let's go negative 2 to 2. Y min, negative 2, y max 2. Now you can press graph. Now I'm going to show you something you've probably never done before. We're going to figure out, now, everybody in y2, you put root 3 over 2. I know the blue graph. Everybody's graphing in blue right now, right? Or black or gray. Okay? The second graph that comes up, why is it a horizontal line? Huh? Yeah, because y2 was just a constant. Anytime you graph just a number, what are you always going to get? You're just going to get a straight horizontal line. Okay? So you should have 2 things. Here's what you do. A lot of you are pushing trace and you are so wrong. You won't find it that way. I need to teach you how to find it. You need to press second trace. I'm going to teach you something in a menu that we're going to start using. This menu we are going to use. It's probably going to be one of the most used menus on our calculator. There's a lot of good stuff. In fact, numbers 6 and 7 are going to be really popular in a few weeks. But we're going to use one here. What one do you think we need? 5. You need to listen. I got them so lost last hour. They didn't listen. They were trying to go ahead. We are going to use the intersection because I want to figure out where that horizontal line intersects that trig graph. Now, how many times does it intersect? So you gotta find it 6 separate times. So you actually have to do what we're about to do 6 times. We're just gonna do one of them, just because I don't feel like doing it 6 times. So press number 5 now. Now, what does it say at the bottom of your screen? First curve, please don't hit anything. If you hit something, you're gonna already be screwed up. First thing that people do is they start hitting the up and down button, which is definitely what you do not want to do. And if you already hit the up and down button, you need to go ahead and hit second trace again, number 5, because you screwed it up. All right, so second trace, number 5. Now, you're going to use your left and right arrow buttons. And it says first curve. What that means is your cursor right now is on the first curve, which I think is the trig one, right? It's on the first curve. It's on the trig graph, because that's the one we put into Y1. You're going to use your left and right arrow. Let's move our cursor, our little X cursor, all the way over to this first point, and you're going to put it exactly where you think it crosses that horizontal line. So you can hold the button down, it'll go quick. And then as soon as you get it, does it have to be perfect? Here's my question, does it need to be perfect? No, it's just got to be close. It's a guess, it's a first curve guess. Once you get it close to where you think that blue and red one cross, or the 2 black ones if you don't have a color one, hit enter. Now it's going to ask you a second question. What's the second question? Second curve. Your cursor should already be on the second curve, which is a horizontal line, close to where you think it crosses that point, that first one that we're looking for. So you should be able to hit enter a second time now. Now it's going to ask you one more question, which is a guess. Your calculator is using bits and pieces of information to estimate this for you. So it's got a first curve guess, a second curve guess, it needs a final guess, and hit enter, and it will tell you the answer. What did we get? Point X equals what? Want to see if everybody got it. What'd you get? Point what?
3.5.
0.35. Right here, this is X equals 0.35, comma what? 0.866 something. Now that 0.866 something makes total sense to me, because that is the 3/2, that's the horizontal line, and that horizontal line is a y value, so that should be 0.866. How did they get the 0.35? That's the question we are going to answer on Monday. So I'm not even going to have you do this tonight. I'm just going to put an optional review thing for tomorrow, and then we're almost to the point where we can solve this. So, be a good introduction, lead in, segue into Monday. After that, listen. Sweet. Since it's chicken nugget day, you better get down.